Hello everyone. In this video I'm going to work through an example of calculating the call value and put value using the Black-Scholes option pricing model, and then we're going to create a program, or excuse me, we're going to create a function in Visual Basic to calculate the Black-Scholes option pricing model. Okay, so let's go ahead and get started here. Our variables are the stock price, the strike price or the exercise price, the risk-free rate, the dividend yield, and that's denoted with a K, the time to the expiration date for the options, and that's in years, and that's denoted with a T, and then the volatility of the underlying stock, and that's denoted with sigma. So what I'm going to do in here is start off with an at-the-money call and put option. So that means our stock price is equal to our strike price. So we're just going to start off with putting in $50 for our stock price, $50 for our strike price, and then I'll put out here, this is our stock price, this is our strike price, and I'm also going to name my cells. So I'm going to go here to B2 and put in stock, and then in B3 I'm going to put in strike. The risk-free rate right now is about 4.25%. So that's what I'll put in here, 0.0425. And I'm going to name this cell risk-free. And I'll also note over here that this is the risk-free rate. We'll go ahead and put a dividend yield in here. And so the dividend yield is the expected dividend for the next year divided by the stock price today. And we'll put in a kind of a normal dividend yield for our dividend paying stock, which is 2%. So I'll put in here 0.02, and that's going to show up here as 2%. And this is our dividend yield. And I'm going to name this div yield. Time, we're just going to start with a 1-year option here, so I'll put this in. And this is time in years. And I'm going to name this cell time. And then finally, sigma, a standard deviation for a regular stock, is probably going to be somewhere around 30%. So I'll put 0.30 in here. And this is again the volatility, or the volatility for the underlying stock, and I'm going to name this one sigma. Okay. So here's the Black-Scholes option pricing model. The C is the call value, the P is the put value. We're going to use put-call parity to calculate the value of the put. So we'll calculate the value of the call option first, and then we'll use that information to calculate the value of the put. We calculate D1 here and D2 here. And those are used in the normal distribution function to determine the values for probabilities. And I'll demonstrate how to do that. And we're going to start off here with D1, and then from that we calculate D2. So D1 says it's the natural log of the stock price divided by the exercise price, or the strike price, plus, and then in parentheses here we have the risk-free rate minus the dividend yield, plus the sigma squared divided by 2. And we multiply all of that area together, that argument, by the time in years. And then we take our numerator and divide that by sigma multiplied by the square root of time. So let's go ahead and do that here. So we're going to start here with D1, and this is equals to, and then in open parentheses we want to put in the natural log, open parentheses. And the nice thing here is that we did name everything, so it makes life a little bit easier here. So we're going to put in stock divided by strike, close parentheses, plus open parentheses, our risk-free rate minus our dividend yield, plus open parentheses, sigma, And then the up caret, so this is shift and then the number 6, the 2 to square that, and then we're going to divide that by 2, close parentheses again, and then multiply that by time. So that's our numerator for D1. Then I'm going to divide this by, and then open parentheses, sigma multiplied by the square root. So in Excel, this is SQRT, open parentheses, time, and then 2 close parentheses. So this gives us our D1 value. Okay. And the value you should get here is 0.225. D2, and I'll just open up that document again to show you that. D2 is equal to D1 minus sigma multiplied by the square root of time. So we're going to take D1 and we're going to subtract sigma multiplied by the square root of time, just like that. And we get negative 0.075. For ND1 and ND2, we're going to use the norms dist function in Excel. So let me go ahead and put that in here. I'm going to put in equals norms dist. And the description in Excel says it returns the standard normal cumulative distribution that has a mean of 0 and a standard deviation of 1. So here we're looking up a probability. So in this case it's 0.58901, and for D2 it is 0.470107. So now that we have ND1 and ND2, we can calculate our call price and we can calculate our put price. Our call price is equal to the stock price multiplied by the exponential function to the power of negative dividend yield multiplied by time, and then we take that product and we multiply it by ND1, and then we subtract the strike price multiplied by the exponential function to the power of the negative risk-free rate multiplied by time, and then that multiplied by ND2. So let's go ahead and do that here. Equal to the stock price multiplied by EXP, open parentheses, negative dividend yield multiplied by time multiplied by ND1 minus the strike price multiplied by EXP, negative risk-free, multiplied by time multiplied by ND2. And we get a value of $6.34 here. And I'm going to make this look a little bit nicer. There we go. $6.34. And then our put price is equal to the stock price, or excuse me, the call value minus the stock price multiplied by EXP, negative dividend yield multiplied by time plus the strike price multiplied by EXP, negative risk-free rate multiplied by time. And so that gives us a value of $5.25. And let me go ahead and put here so you can see all the formulas. So this can be a little time consuming to do if you have to calculate a lot of different stock options. Now I'm going to demonstrate how to create a Visual Basic program that'll do this for you. And all you need then with the Visual Basic program is the inputs, and it's going to calculate your call price, and it's going to we'll do one for the call and we'll do one for the put. Okay, so let's go ahead and open. Well, first let's save this. I'm going to save this, and we'll need to save this as a macro enabled workbook. And then I'm going to go out here to Developer and open up Visual Basic. And in my notebook in my workbook that I created, I'm going to insert module. And I'm going to create a few different functions here. So I'm going to break this down to make it a little easier to do into a function for calculating D1, and then a function for calculating D2, and then we're going to embed those in our our function for our call, and then we're going to embed all of those functions into our function for the put option there. I'm going to create the first function I'm going to create is for the D1 in our calculation. So I'm going to put it out here, function D1, and then open parentheses. I need to declare my variables now, so I'm going to put in stock for my stock price, strike for my strike price, time, risk-free for my risk-free rate, div yield for my dividend yield, and then sigma for my volatility measure. So we'll put in here D1 is equal to, open parentheses, log, so we're taking the natural log here, of the stock price divided by the strike price, plus, open parentheses, risk-free, minus the dividend yield, plus open parentheses 0.5 multiplied by sigma, in close parentheses there, squared, squared, close parentheses again, and then multiply that by time, close parentheses. Then we're going to divide that by, and open parentheses, sigma multiplied by the square root. And in Visual Basic, we use SQR instead of SQRT. So that's a difference between the Excel function name and what it's named in Visual Basic. So remember, this is SQR instead of SQRT for the square root. Open parentheses time, there we go. Open parentheses, time, and then two close parentheses. Okay. So there's our D1 function. Now we're going to create our D2 function. So function D2 So what I'm going to do now that I've created my D1 function, before I move on to D2, I want to make sure that everything works all right. So I'm going to go back out to my spreadsheet. I'm going to try it out. Okay. So I'm going to go out here, and I've got D1 over here. So I'm going to just put in here equals D1. And that pulls up my arguments. So my stock is equal to my stock price. My strike is equal to my strike price. My time is equal to my time of 1. My risk-free rate is 4.25%, and then my dividend yield is 2%. I need to scroll this down and then put in my sigma, and I get an answer of 0.225, and it checks out. It's the same over here. So since that checks out, I'm going to move on now to D2. So I'm going to put in here function D2. It's going to have the same inputs as my D1. So stock, strike, time, risk-free, div yield, and sigma. So D2 is equal to D1 and then it gives me an instruction here of what to put in. So you have to put in all of those variables that are the variables for D1 in there. And that's also why we have to declare them in the first row. D1 minus sigma multiplied by SQR, so again that's the square root of time. Press enter, and now again what I did last time I'm going to do again this time. I'm going to go out and test this out, so I'm going to save this. I'm going to minimize that. I'm going to put in equals D2 and then press my button there. So stock is equal to, again, 50. The strike is the strike value. The time is the time value. The risk-free rate is the risk-free rate. The dividend yield is the dividend yield. And then finally, and again, remember we need to scroll down over here to put our sigma in. We get negative 0.075, which matches what we have here for D2. So feel good now that my D1 and my D2 functions are working. All right, so now let's go ahead and put these two functions, D1 and D2, into a third function for the Black-Scholes call value. And we're going to name this one BS call. We need to declare, again, all of our variables. So I'm going to put in stock, strike, time, risk-free, div yield, and sigma, close parentheses. And so BS call, the call value is equal to the stock price multiplied by, open parentheses, is equal to the stock price multiplied by EXP, open parentheses, negative the dividend yield multiplied by time, multiplied by, and now we're going to include the norms dist function, so we need to put in here application, period, norms dist, open parentheses, and now we're going to use that D1 function, D1, and because we've already put this in our module here into our Visual Basic, it pulls up all of the different variables that we need to put in. And then one more parentheses, and now I'm going to go to the next line because we're going to get near the end of the line here. So I put in a space and then an underscore, and now I'm going to put in minus my strike price multiplied by EXP, open parentheses, negative, risk-free, multiplied by time, multiplied by, and now we're going to use that norms dist function again, so I'm going to put in application dot norms dist, open parentheses, D2, and I'm going to again put in all of my variables. and then one more parentheses there, press enter. We're going to save it, and then we'll go out to our spreadsheet here, and we're going to try it out. So I'm going to put an equals BS call, open parentheses, select the insert function button, put in the stock price, put in the strike price, put in the time, down here, time, put in the risk-free rate, put in the dividend yield, and then finally I need to scroll down here to my sigma, and I get my answer of $6.34. Okay, so we have one last one to do, and that is our put value, our put price, and we're going to use this equation here, the call price minus the stock price discounted back at the dividend yield multiplied by time, plus the strike price discounted back at the risk-free rate multiplied by time. We'll need to call up the BS call function, and so that's what we're going to do in Visual Basic here. So let's go out back to our Visual Basic screen. I'm going to call this one function BS put. We're going to have all of the same variables because we need to include all the same variables because we use them in the function in the formula, but also because we're going to be calling up this BS call function as well. So BS put is equal to the call value, BS call, and then we're going to put in stock, strike, time, risk-free, div yield, and then sigma, close parentheses. Then we subtract out the stock price minus stock multiplied by EXP, open parentheses, the dividend yield multiplied by time, close parentheses, plus the strike price multiplied by EXP, open parentheses, negative, risk-free, multiplied by time. Okay. Got it all in there. Press enter. I'm going to save it now. Minimize that. Now I'm going to calculate my put value. I'm going to put in equals BS put. Select my insert function button. My stock price is 50. My strike price is 50. My time is 1 year. My risk-free rate is 4.25%. My dividend yield is the 2% here. And then I'm going to go over to the right side and scroll down, select my sigma, and I get a value of $5.25, which matches the value that we have here. So everything matches up here. This has been a demonstration on how to calculate the call value and the put value of a stock option using both functions that we can put in Excel here, and also some Visual Basic functions that we created. With the Visual Basic functions, we also demonstrated how to embed one function into another, and also to call up applications from Excel into our Visual Basic program to use them there as well. Please let me know if you have any questions about this.